Okay, guys, so in this episode, we are going to look at a pure exchange economy. There is no production, but we introduce the concept of price. So instead of allowing these agents to do barter exchange, give me one potato, I'll give you two banana, for example, we are going to introduce price, money in a sense. So that means I can sell you apples as money, all right? And then with that money, I can buy bananas, all right? So the transfer is going to happen through money. Well, the question is, how much money are these going to bring? So we assume that, don't take this, there exists money thing too literal, all right? So the money doesn't really exist. It's like, it's just, let's say these two guys who are planning to make a trade create this notion of price, okay? So there is no actual money, but they create this notion of price. So I'm going to, I'm not saying one apple is equal to two banana, but I would like to say one apple is $5 and one banana is $3 or something like this, all right? So they create this notion of price, and then see if things are going to be different with this idea of price incorporated. The question we are after is like, well, what is the sort of equilibrium price levels so that these two guys make an exchange or make a trade in this market? All right, so we assume, again, there are two individuals, two agents, A and B. They bring some good 1 and good 2. So these are their initial endowments. That's all we know. So suppose, as I said, they introduce this concept of price into this market. So there's going to be price for good 1 and price for good 2. Who determines this price? No one. Is it God-given? No. How is it going to be determined? Well, it's going to be determined in the market by these two agents. How so? Well, we assume, again, remember, this is a perfectly competitive market. Well, there are two agents. How come it is perfectly competitive? Well, this two agent thing is just a simplification assumption. All right? So think of like there are 1,000 agents of type agent A and 5,000 agents of type agent B. So there are total a lot of guys, but there are actually two types. I think it that way. So, given that, so that means these agents, when they get together, they create some supply and with their initial endowments and demand for these two goods. So the trade is possible, but there's a price P1 and P2. So these prices will be determined within this market. And so it is a perfectly competitive market. That means the price should be the level in which supply equals demand. All right? So that's the idea of perfectly competitive market price. So we are going to introduce the equilibrium condition later. But first, what is the question or what is the optimization problem these guys are solving in this market? Well, simple. Agent A's decision is going to be the following. Look, I have good 1. I have good 2. Oh, I am sorry. These are, I am terribly sorry. Wrong notation. These are W1A, W2A, W1B, and W2B. All right, so these are initial endowments. Sorry for my notational mix-up. So agent A's decision is simple. I'm going to maximize my utility, right? I'm going to choose good 1 and good 2 to maximize my utility. However, I am subjected to some budget, right? So there's a price of good 1. So if I buy X1A unit of good 1, this is going to be my expenditure. This is going to be my expenditure on good 2. So this is my total expenditure. I know that my total expenditure cannot exceed my total quote-unquote income. What is income in this market? Remember, this is a pure exchange economy. There's no production, there's no wage, there's no income in that sense. However, what I bring to this market is actually my income, right? Because I can sell my good 1 at a price P1 and good 2 at a price P2 and make that much money. And then later re-optimize, in a sense, choose X1 and X2 to maximize my utility subject to my expenditure is less than or equal to my income. Obviously, my utility function, we're going to assume, is increasing, and so leaving money or not spending money is pointless, right? So therefore, I can just simply assume that my expenditure should be equal to my income. Well, exactly the same thing for agent B. Well, this is what each agent is going to do. Agent B will also maximize by choosing what? X1A, X2A for agent A, and X1B, X2B. So these are all greater than 0 or equal to. So agent B will also maximize his or her utility subject to her budget constraint, right? Her expenditure on good 1 and good 2 has to be equal to her income, where her income is basically the value, the monetary value of her initial endowment, given the price of good 1 and good 2. Again, what are those prices? We don't know. It is going to be determined in this market. How? Well, remember we said this is a perfectly competitive equilibrium. So the equilibrium condition was supply equals demand. Well, or demand equals supply, because I wrote it this way. So what is supply in this market? Well, look, physically, we brought W1A plus W1B amount of good 1. We don't have more apples than this. So this is how much apple or good 1 we have. So therefore, your consumption, your demand for good 1 shouldn't exceed. So we shouldn't have excess demand, or we shouldn't have excess supply. That's the idea of perfectly competitive market, remember. So the demand for good 1 must be equal to demand for good 2. Well, obviously, the same true for good 2. Demand for good 2 must be equal to supply of good 2. So we call these market clearing conditions. All right? Well, that's it. So that's basically the problem these two agents are facing. But how can we solve these prices? Well, simple. If you solve these optimization problems, you are going to create the demand curve for agent A and demand curve for agent B, right? So this is market demand, aggregate market demand. Well, we already know the aggregate supply, so we're going to equate supply and demand and solve the price, because we know that demand curves are functions of prices. So this term is going to be a function of price. This term is going to be a function of price. These are known numbers, right? No number of apples and bananas are known. And so therefore, I can solve the prices. All right? One thing though, we normally, you'll see in this very simple example, there will be infinitely many possible equilibrium prices. All it matters is relative prices. That's all it matters. Meaning, what is the price ratio, P1 divided by P2? That is actually the question. So we cannot pin down what exactly P1 is. Is it $5, $2? No. What we care, or what we can find, is the relative price ratio. Okay? So you'll see it with this example. So that's the example I solved in the previous video. Remember, so this is the utility of agent A, utility of agent B, the initial endowments as such. So what is agent A's maximization problem? Maximize utility, which is x1 times x2, subject to the budget constraint here, P1 x1A, P2 x2A equals, remember she's bringing 2 good 1, so it's 2P1 plus she's bringing 1 good 1, a good 2, so just P2. Well, how can I solve it? Easy. Margin rate of substitution of agent A equals to the price ratio, remember? So if you solve this, this is what you're going to get. And then I'm going to plug this to the budget curve, right? And solve for X2A and X1A. I already did that. So you see, this is the demand curve for good A, demand for good 1 for agent A, all right? And obviously they're functions of prices. I'm going to do exactly the same thing for agent 2. Agent B. Agent B maximizes her utility, which is x1 plus x2, subject to her budget constraint. Well, here be careful, her expenditure is kind of the same. It's just instead of A, I just put B because these are the agent B's consumption or demand. And here, the initial endowments are different, right? So be careful about that. So if you solve this, how? Well, margin rate of substitution of agent B, which is fixed, minus 1, equals to the price ratio, which is minus P1 over P2. All I can learn from this exercise is that P1 has to be equal to P2. Okay, well, but the thing is, what is the demand for good 1, demand for good 2? Well, simple. Once you figure out what the price ratio should be in equilibrium, you go back to the demand curve for agent A, all right? And plug the, whenever you see P1, just plug P2. So it's going to be 2P2 plus P2, 3P2 divided by 2P2. P2s will cancel out because we assume the market price will be some positive number, right? Zero price makes no sense unless the utility functions are too weird. So therefore, X2A is 3 over 2. What does that mean? That means agent A would like to consume 1.5 unit of good 2. And he wants to consume exactly the same amount of good 1. All right? Well, what about agent B's consumption? What is going to be her demand? Well, simple. For this, you need to use the equilibrium condition. Supply equals demand. So here the demand is X1A plus X1B, right? So I know X1A, it's 3 over 2. I know that the total supply is 3 units of good 1. So therefore X1B has to be again 3 over 2 and X2B has to be same 3 over 2. So therefore, what did we learn? Well, we learned the following. If this is the scenario, meaning if we have 2 agents with these utility functions, with these preferences, and with these initial endowments, in this market, if they trade, well, this is what the outcome will be. In equilibrium, price of good 1 will be equal to price of good 2. All right? So P1, P2 ratio is going to be 1. So if P1, for example, is $5, P2 will also be $5. Well, if P1 is 10, P2 will also be 10. Again, remember, all we care is the relative price ratio. What else? Well, we know that X1A is going to be equal to X1B, which is equal to X2A, which is equal to X2B. Basically, they share everything. They split everything equally. All right, that's the outcome. Well, if you draw the Edgeworth box again, remember A, B, this is a 3 by 3, 1, 2, 3, and this is 3, 2, I'm sorry, 1, 2, 3, same 1, 2, 3, and then finally 1, 2, 3. 2 should be somewhere here. So the initial endowment, so if you remember, that was the optimal allocations, right? That was contract curve. If you don't remember the previous example, please go back to the previous video. Well, where was the initial endowment? The initial endowment was this point, 2 good 1 and 1 good 2 for agent A. And then if you remember, we said this is agent A's indifference curve, UA, the initial indifference curve. This is agent B's indifference curve, U of B. So what we figured out, we said whenever X1A is in between square root of 2 and 3 over 2, all those allocations, and same for good 2, square root of 2 and 3 over 2, all those allocations are core allocations. However, we now found the following. If these guys actually introduce the idea of money or price, well, then actually they are going to trade and end up exactly this point. All right? Why is that so? Well, I mean, first of all, this is the 3.2 for good 1 and good 2 for agent 1 and A and B, right? So this is going to be, so it is, as you see, so this is one of the core allocations. This is one of the proto-optimal allocations. Agree? So, let me put it this way. Remember, our question was the following. If these guys come together in this market, will they ever trade? And if they trade, what sort of allocation are they going to end up with? Well, we said the final outcome should be feasible. It should be proto-efficient, meaning has to be on this 45-degree line. And then we said it has to be a core allocation. We said it has to be in this region. But now, by introducing the concept of price, We even narrowed down our prediction and we said, hey, look, you know what? If price is introduced, actually they're going to end up trade and end up at this point. All right, so this is where they started and they should trade and end up at this point. Question is, why this point? Well, we asked why exactly this point? Why this is going to be the final allocation when they do trade? Well, here is the reasoning. I'm not doing something new. I am just picturing what optimization problem these agents faced and solved. So remember, these agents start with this initial endowment. All right, so and they maximize their utilities subject to their budget constraint. Remember, P1x1a plus P2x2a is equal to W1a plus P1w1a and P2w2a for agent A and similarly for agent B. So this is the budget constraint. So basically I am supposed to draw a budget curve here, a budget set here, and then figure out where the optimal solution for agent A is going to be. Well, here obviously the optimization problem, or not the optimization problem, but the slope of the budget line depends on the price ratio, right? If you remember the good 1, good 2, the slope of the budget line is always equals to minus, but forget about the minus sign, P1 over P2. So if P1 is greater, it's steeper. If P1 is smaller, so it's going to be a more and more horizontal. So that's the idea. Well, one thing though here, so therefore the P1 over P2 ratio is going to determine how steep the budget curve will look like. But don't forget, the budget curve must pass through the initial endowment. Why? Well, because this is how we generated income for those guys. Remember, the income, so this is not P1x1 plus P2x2 equals I. Well, so these terms are not going to be I divided by P1, I divided by P2. They are going to, here the income is this guy. So that means whatever the budget line is, or whatever the slope of this budget line is, the budget line must actually pass through the initial endowments. All right, so that's very, very important that you understand. So therefore, for example, if P1 is equal to P2, this is what the budget curve is going to look like. If P1 is greater than P2, this is what, for example, a budget curve will look like. If P1 is less than P2, for example, this is what budget line will look like. Okay, so different price ratio is going to give us a different budget curve. But whatever the slope of the budget curve is, so let me clear all this, and let's leave just one of them. And on purpose, I am going to leave the budget curve that is that has exactly slope of 1. So whatever the slope of this budget curve, remember these guys are solving the following optimization problem. Given the budget line, therefore this is the budget line for agent 1. And if you look at it from agent B's perspective, this is his budget line, all right? So what does that mean? That means agent A's optimal point is going to be this, where his indifference curve is tangent to his budget line. And symmetrically, agent B's indifference curve is going to be tangent to his budget line at some point. And actually, it is exactly this point. And so this is exactly why we found this as the solution. Well, by the way, this blue curve is not the indifference curve for agent B, because the utility function of agent B, if you remember, is x1 plus x2. So they are straight lines. The indifference curves are straight lines. But again, without loss of generality, let's suppose agent B also has convex preferences, very much like agent A's utility function. So therefore, this should be the equilibrium. All right. And so in any equilibrium, this is what we must have, right? I mean, you cannot have, for example, I am going to need another sort of graph, I believe, because otherwise it's going to be a very complicated picture. So again, this is the initial endowment. All right, so let's suppose this is the price ratio. Okay, let's suppose. Well, if you do the utility maximization problem, probably, so here the P1 divided by P2 ratio, as you see, is less than 1. Okay, so here, if you solve the utility maximization, probably the optimal point allocation for agent A is going to be this. So this is X1A and this is X2A, all right? And if you do the optimization, again, the same line is a budget line for both agent A and B. It's just from which perspective you're looking at, all right? So if you're looking at from agent B's perspective, well, this is the budget set, all right? If you're looking from the agent A's perspective, well, this triangle, well, it's not really a triangle, but this area is the budget set. Okay, so be careful about it. So if you do the optimization problem for agent B, well, again, let's suppose she also has a convex preferences like agent B. So this is what her consumption bundle will be. All right, X1B and X2B. So what does that mean? That means this is how much good one, so this is X1A. So how much good one agent A would like to consume. And I should have written it this way, X1B, and this is X2B, all right? Sorry about that. And this is exactly how much good one agent B would like to consume. Well, what do you see? Well, you must be seeing the following. Agent A is consuming this many good one. Agent B is willing to consume this many good one. What happens, this portion, let me use a different color. This portion of good one is not going to be demanded by these guys. So in this case, this is going to be less than W1A plus W1B. I hope this is obvious. Again, so this is the demand of agent A, this is the demand of agent B. So this portion, remember, feasibility says this entire part of this square is available good one. So good one demand for agent A and B is clearly less than supply. So therefore, this cannot be equilibrium. All right? So what we should increase the prices, or the market price should increase automatically because there's going to be excess supply for good one. All right. What does that mean? That means price of good one. So there's an excess supply. Yeah. So the price of good one. We can say, for example, price of let's decrease the price of good two. All right. So let's make it cheaper. So change this price ratio. And so try to come up with allocation where supply is always equal to demand, not only for good one, but also for good two. So again, if you come back here, well, this should be the competitive equilibrium outcome, because this is how much good one agent A would like to consume. And this is exactly how much good one agent B would like to consume. And as you see, the demand X1A plus X1B is exactly equal to the total supply. So demand equals supply for good one and also for good two. All right. So the market clearance condition holds for each good, and hence this should be equilibrium, but this can't be. All right. So basically, this optimization problem and the market clearing condition is sort of searching P1, P2 ratio, such that those optimal points create demands where they are equal to the supply for both goods. And so we pin down that exact price ratio. And in this example, that price ratio happens to be 1. All right? Obviously, this outcome depends on the initial utilities, preferences. If agents have different preferences, obviously the price ratio will be different because the demand will be different and the final allocation will be different. Also, it depends on the initial endowments because if, for example, the initial endowment is more skewed towards one of the agents, well, then the price ratio is going to be different probably. So therefore, the outcome and the price ratio will also be different. All right?